Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-2 Extra Practice Number 5 solutions on operations with functions. For this first problem, we've got the h and the g function, and we want to find g composition h of s minus 3. So basic idea here is we have to take this s minus 3 and first plug it into the h function, and then whatever we get out of that, we have to plug that into the g function. So we've got a few steps here. So first, let's figure out h of s minus 3. So that's going to be taking the s in this formula and replacing it with s minus 3. So I'm going to rewrite this as 2 parentheses s minus 3 minus 4. Now let me distribute and simplify. So this is 2s minus 6 minus 4. Which I can simplify to 2s minus 10. And I'd like to simplify as I go because I'm going to be turning around and using this elsewhere. So the less I have to work with, the easier it'll be later on. Next up, now I have to take this 2s minus 10 and plug that into the g function. So g squares stuff and adds 9. So we're going to be doing 2s minus 10 squared plus 9. I'm going to expand this now using my a squared plus 2ab plus b squared shortcut. So squaring the first thing gives me 4s squared. Multiplying these things together and doubling them gives me negative 40s. And then finally, negative 10 squared is positive 100. And don't forget that 9 we still have floating around there. So combining like terms, I can write this as 4s squared minus 40s plus 109. And that's it for this one. For this next problem, we are taking the f and the p function and multiplying them together with negative 2 plugged in. So in terms of my strategy, I'm actually going to figure out f of negative 2 and p of negative 2 separately, and then whatever I get, I'm just going to multiply those two answers together. So let's do f of negative 2 to start off with here. That's going to be negative 5 times negative 2 plus 6. That's that's positive 10 plus 6, which is 16. Next, let me figure out p of negative 2. That's going to be negative 2 cubed minus 3 times negative 2. So negative 2 cubed is negative 8. Negative 3 times negative 2 is plus 6. Negative 8 plus 6 gives me negative 2. So just like I said, I'm going to take the results of f of negative 2 and p of negative 2 and multiply them. So I'm going to do 16 times negative 2, which comes out to a final answer of negative 32. For number 3, I'm taking the h and the f function, and I'm doing a composition of h on f with q plugged in. Now, since the thing I'm plugging in is exactly the same as the placeholder variable here, I don't really need to change the f function much. I just need to take the f function as is, 3q minus 7, and plug that into the h function. So I'm doing h of 3q minus 7. So that's going to be negative 5 parentheses 3q minus 7 plus 4. Just erasing and replacing q with 3q minus 7. Next, I'll distribute. So that's negative 15q plus 35 plus the 4 that was already there. And that simplifies to negative 15q plus 39. For this next problem, we have the g and f functions, and we're doing f plus g of d. Since we're just plugging in d, that's essentially just giving us the original functions the way they're written. We're just adding the two functions together. So we have all this f stuff, 5d plus 9, plus all the g stuff over here, d squared minus 11d plus 10, and I'll put them both in parentheses, but I don't really need to. So we've got d squared, if we combine like terms here, and then 5d plus negative 11d adds up to negative 6d, and then we have 9 plus 10 giving us 19, and this is as simplified as it gets. For number 5, we have a p and a g function that we are plugging negative 10 into, and then we have to divide the results from doing that. So let me find these individually and then divide. So p of negative 10, that's going to be negative 10 cubed minus 3 times negative 10. Negative 10 cubed is negative 1,000. Negative 3 times negative 10 is a plus 30. So that comes out to a total of negative 970. Next up, let's figure out g of negative 10. That's going to be negative 10 squared minus 8 times negative 10 plus 6. So that's 100 plus 80 plus 6, or 186. So that actually worked out pretty well. Now we have to do p divided by g. So negative 970 divided by 186. And I think we can definitely reduce those by 2. So this would be negative 485 over 93. Can we reduce that anymore? Not really sure. 93, you could split that up into 3 and 31. 3 doesn't go into 485 because the digits don't add up to a multiple of 3. 31, I'm pretty sure, doesn't go into that either. So I'm going to say this is as good as it gets. For number 6, we have an h and an f function. We're doing h minus f of 5. So what I'm going to do is plug 5 into each of these individually and then just subtract whatever I get from doing that. Let's do h of 5 first. That's going to be negative 9. Negative 9 5 squared minus 5. So 5 squared is 25 times negative 9 is negative 225 minus another 5 is negative 230. Feel free to do that on the calculator though. And then 5 going into the f function. That's 7 times 5 minus 3. That's a lot easier. 35 minus 3 is 32. So if we're subtracting these, then we're doing negative 230 minus 32. And that comes out to negative 262. For number 7, we're just doing h minus p of n. Since we just have the original variable plugged in there, we're essentially just taking h and subtracting p from it. So 4n squared minus 6 minus, and I'll use a parentheses for this, n cubed minus 7n. So let me pop that first parentheses because I don't really need it. The next one, though, I have to distribute this negative. So negative n cubed, and then negative negative is plus 7n. And I've got all like terms combined here. There's no duplicate variables or exponents. However, I can put these in order. So I'll write negative n cubed first, plus 4n squared, plus 7n, minus 6. For this next problem, we're doing h of negative 4 plus g of negative 4. So I will just figure out what happens when I plug negative 4 into these individually and then add those results together. H of negative 4, that's going to be negative 9 times negative 4 squared minus 2. Negative 4 squared is 16. Negative 9 times 16 is negative 144. Minus another 2 is negative 146. And then g of negative 4, that's going to be negative 4 squared plus 11 times negative 4 minus 7. So this is going to be, let's see here, 16 plus negative 44, so negative 28, minus a 7 is going to be negative, hold on a sec. Yeah, 16 minus 4 minus, yep, that's negative 35. I actually showed my steps there. And then we have to add these together, so negative 146 plus negative 135. This is going to be negative 181. For number 9, we have a p and an f function. We're doing p of negative 7 minus f of negative 7. So let me figure out these plug-ins individually and then subtract them. So p of negative 7, that's negative 7 cubed minus 11 times negative 7. Negative 7 cubed, that's negative 343. I just happen to know off the top of my head, but feel free to use a calculator. And then this will be plus 77. So let me think here. That would be negative 266. Yep, if we add those together. Now we'll do f of negative 7. That's 7 times negative 7 plus 10. That's negative 49 plus 10, which is negative 39. And now if we do negative 266 minus negative 39, that's really plus 39, giving us, let's see here, is that negative 227, I think? Yep, 227. There we go. For our last problem, we have f divided by p of y. So basically just taking the f function here, 9y plus 5, and dividing it by the p function, y cubed minus 3y. Now we do need to look to see if we can simplify this any further. We could take out a y as a common factor from that denominator, but you're not going to be able to do anything in terms of canceling with the numerator, so we'll just leave it the way it is, and that is the final answer. So that's it for this extra practice. Till next time, Mr. Sutton signing off.